So our next presenter is Dr. Paul Knuch. He's the Life Adsorb Project Manager and Head of the Water Cycle and Water Quality at the Water and Cleanliness Department in Paris. Good morning, Paul. How are you?
I'm good. Hi.
Great.
Can you hear me well?
We can hear you perfectly, and we're looking. This is an amazing work you're doing in Paris. We just had a little chat about it yesterday. Huge investment and big outcomes for Paris. So we look forward to your presentation. I'm going to hand it over to you.
Thanks. Hi, everyone. Thanks again for the invitation. I'll share my screen and let me know. Oops. Okay, that should be displayed now. Okay, thanks. So as Ruth mentioned just before, there's an echo. That working now? Yeah, okay. Thanks. As Ruth mentioned before, I would have liked very much to join you, but same thing, in case you have any questions you'd like to chat about what I'll present, don't hesitate to drop an email. So I'll talk about what we're doing in Paris right now. It's quite an ambitious presentation, to be fair. In 15 minutes, I'll try to give you a short brief of what we're doing. And hopefully that delivers a good message. So right now in Paris, we're working on our river quite a lot. So it's called the Seine. And today I'll focus on disconnections and misconnections. As some of you may know, there's a big project to make the Seine swimmable. So the project will start as of in 2 months, where the Olympics and Paralympic Games are supposed to take place in the Seine for a few sports such as triathlon and swimming, but the eventual goal is to have a legacy of the Olympics with a possibility to swim in the Seine by 2025. So right now it's kind of a rush in Paris, as you can imagine. I'll just go through this story shortly and then present 2 examples of misconnections and disconnections. So this is the Parisian region. You have Paris right there and the Seine that flows through Paris. There's another water body in Paris, the canal, that comes from the north and then joins the Seine around Bastille, for some of you who may know Paris. The Seine is fed by the Seine itself and by the Marne, which joins just before entering Paris. And of course, as you may imagine, the quality of the Seine in Paris is very dependent on the quality of the rivers coming through it. We can already bathe in the canal that started in 2017. But bathing in the Marne and the Seine is not yet possible, but should be possible by 2025. So in order to manage to get to a bathing Seine, a big plan started with a candidacy for the Olympic Games, and a governance structure was created in 2016 around that water quality action plan. It was led by the mayor of Paris, Anne Hidalgo, at the time, and still nowadays, and the prefect of the Île-de-France region. It brings together over 30 stakeholders. There's a lot of cities upstream from Paris, a lot of actors involved in treating water, collecting water, or like handling boats and all sorts of activities. These stakeholders were divided in 6 working groups. And more than 50 actions were planned in the action plan to treat pollution from rainy or dry weather. So as I just mentioned, 2024 is a big step for us with the Olympic and Paralympic Games, and 2025 should see the legacy where bathing for all will be possible. So the big project is divided in 6 actions, as I mentioned. I'm only listing 5 here. The starting one was to improve the knowledge that we had on water quality. So really, that's been looking at the water quality along the Seine and the Marne upstream from Paris to kind of manage to identify the most problematic pollution sources in the water. Reducing contamination from treatment plants by adding extra treatment, reducing discharge from wastewater from the boats that are in Paris. There's quite a lot of boats in Paris, so they've all been connected to the sewer system. And then the two topics that will interest us today is reducing the discharge of wastewater during dry weather periods. So that's really a problem of treating misconnections. As you can see on the map, so Paris is this little circle. In Paris, 95% of our sewage system is a combined system, so we don't have this problem of misconnection. But the upstream from Paris, this pale yellow, and north of Paris, we have separated systems with a lot of misconnections to fix. And the other part was to reduce the discharge of untreated wastewater when it rains because of our CSOs and combined system in Paris, and because it's such a dense city, if you've ever been, and so it's really a challenge to manage to be resilient during rainy periods. So there was also a plan on that, and that's part of the project I'll be presenting in the second part. So let's go to the misconnections. That was one of the most ambitious actions. I guess most of you who work on that topic know how hard, and I've seen in the previous presentation, it is to fix misconnections on such a dense territory, as just been explained in Edinburgh. So I think you all know what a misconnection is. So where we have either a connection of rainwater in the wastewater, or the opposite, the wastewater going to rainwater system and ending up in the river, which is of course quite a problem for environmental reason, but also when you want to reach baseability of a river. So a campaign was started. The objective was suppressing 25,000 misconnections. So both types of misconnections were involved and were targeted. This went with the launch of a communication campaign. You can see that little one. That's one of the example to try and communicate with the broad audience. And the dedicated website was created, mynetwork.fr, basically, to identify whether you were in a separated system, in a combined system, and who you were supposed to ask, to contact, to know whether you were connected properly to the wastewater system. Several lines of actions were started as incentives to push people to check their connections, because of course people are not really willing to do that by themselves. An Olympic law was passed to prepare the Olympics in 2018, and it made it mandatory. Basically, when you want to sell your house, your buildings, or whatever, you have to get a certificate that you're compliant and that your wastewater is going in the wastewater network and your rainwater is going in the rainwater network. Otherwise, you can't sell your house. So because Paris is such a dynamic place in the Parisian region, that's worked quite well to push people to get their houses checked. All the public buildings were systematically checked. There's also been agreements with hotels, for example, was a lot of inhabitants, if I may say, on a quite dense areas. That was also a good target to reduce the pollution flow to the Seine or the Marne. This was financed by public money. There were public subsidies of up to 4,200 euros for works in individual houses, and in collective housing it was based on the number of inhabitants, so 420 euros per inhabitant. Also, the territories concerned by these misconnections, some of them offered free diagnostics to make sure you were compliant or not. The city of Paris itself gave additional subsidies to the 4,100 euros to reduce the cost for individual houses to the most vulnerable and crucial territories with which were the ones identified with the most problematic misconnections. These misconnections, actually, maybe I should have started by that, have quite an impact during dry weather. That's a representative graph of what was expected from the fixing of the misconnections. So if you measure water at the Olympic site, that's a model. But basically, you see that if we were to cut the 25,000 misconnections, there's an expected reduction of 20% for both fecal indicator bacteria, so E. coli and Enterococci. So that's quite something. As I said, it's quite a challenging action. So right now, we estimate that we've reached approximately half of the objective. So we're not quite there yet. That's one aspect of the plan that's really challenging. And I'm really interested to hear what the next speakers have to say on techniques to improve the diagnostics and the fixing of misconnections, because I think that's something we're going to still have to work on for the legacy swimming. But we're still working on that. Switching without transition to the disconnections, because that's another part of the plan where we wanted to reduce the input of rainwater to the sewage system to diminish CSOs, basically. So that's the Life at Soar project, and that's actually how Lauren got in touch with me through that project. It started in 2019 and will finish in 2025. We've extended it for 2 years. Basically, that was a project around getting an innovative filter to reduce the pollution from road water, from the central road around Paris, the Ring, to the environment. It had 3 objectives: so reducing the pollution rejected to Seine by 95%, testing a new system to treat red waters, and integrate that system in a very dense setting, as I said, and in a classified natural site, and to increase its biodiversity. So this is Paris again. I'm quite obsessed with my maps. You can see the Bois de Boulogne here. So that's a big park on the west outskirt of Paris. The filter is implanted at the pink dot here. It's collecting water from the Parisian Ring Road, the blue catchment area you can see here for the road, but also unitary catchment from that neighborhood. So basically, we got 21 hectares from the Ring Road, which is circulated by 200,000 vehicles a day, and around 70 hectares of a unitary catchment. So the idea was to collect the water from the Ring Road or the unitary catchment, bring it to the reed bed filter, and then send it to the Seine, once the water was cleaned. You can see pictures taken from a drone. There's actually 2 filters, not only one. It's actually easier to see in the winter conditions. You have two separate inputs for the conventional filter and the innovative filter, and then a single output that's rejected to a river in the park that goes to the Seine eventually. Both of them are around 700 square meters. What you can see is a difference in the composition of these filters. So the reed bed filters, you can see the conventional one basically has a filter layer of 40 centimeters. It's only composed by sand, while the innovative one is a mixture of sand and rain clean. That's an industrial adsorbent substrate that we wanted to test in real conditions, and that was chosen after lab testing. The rest of the filter is the same. There's drainage layers with gravels of increasing size, a drainage system, and that's about it. So in the project, one of the aspects I'll focus on is the substrate, the evolution of the substrate and the contamination of the substrate. We see accumulation of sediment, so particulate matter on the surface, and so these particles were studied, as well as the rain clean and the sand, to see how contamination was deposited on the filters. That's an image of the 3 campaigns that have been run, so from 2020 to 2022, where several samples were taken from upstream to downstream of the filter. at a depth of 40 centimeters. You can see what it looks like on these little pictures. And we got 43 composite samples for all the different campaigns in the two filters. We studied the physico-chemical properties of these substrates, the concentration of trace metals, of organic micropollutants, but also the evolution of microbial communities. Unfortunately, I can't talk about everything today, but that's what's been done on that. What we've seen is that the representation of the sediment thickness in these maps, that the input and the output of the filter, you can see that just the upstream zone. We see that we have sediment deposited at the input of the filter. It's increasing over the years and increasing with this decreasing, with distance to the input as expected, and we see an accumulation rate of 4.1 cubic meters a year. So really, this sedimentation is crucial in the filtration and in the improvement of the quality of the water that's released to the sand. I'm showing here also the types of contaminants we find associated in these filters. So we see that basically the most contaminants are associated with correlated with the concentration of organic carbon. You can see for most heavy metals, cadmium, copper, lead, zinc, but also for organic micropollutants. We see that it's negatively correlated to the distance and the depths at which we were sampling. We also see that there's some metals like nickel and chromium that have higher mobilities, so they don't get associated with particles and they don't get at the surface of the filter. They migrate through the filter, and they need to be absorbed to be retained. And we do see a spatial heterogeneity of accumulation. Just to show you that the results are not quite as good as we expected, we have different accumulation rates for metals on the left and organic micropollutants on the right. So the filter with the sand is the orange one, the filter with the rain clean is the blue one. We do not see much of a difference in the accumulation of pollutants. So it seems like a classical filter is doing the same job or almost the same job, at least for the first 2 years of operation. We'll need to keep analyzing that through the years. What we see, though, is that there's an increase in the accumulation of trace metals through the years, while we don't really see that for the organic micropollutant, except for NP, which is most likely due to biodegradation by the microbial community that we've sampled. And that's quite interesting to see that this retaining it on the pollutants on the filter enables us to get natural degradation of these pollutants. That's just a big conclusion slide. To recap what I've said, we do see most metals and pollutants being retained at the surface of the filter, upstream from the filter, showing that probably we'll be able to operate this filter for quite a long time before having to change all the materials. We do see some metals with higher mobility being retained more downstream and at the level of the depolluting surface, the rain clean, which has a very limited role. We do see, and I've not shown that, I'm sorry about that we are having a drastic improvement in water quality that's released to the natural environment while getting some of the rainwater outside of the sewage system, so therefore limiting the overflows that happens whenever it's raining. Which should hopefully lead us to successful Olympic and Paralympic Games starting from July, and something that should look like that for legacy basing. So we invite you to Paris in 2025, summer 2025. Hopefully you'll be able to enjoy that. I'm sorry, I think I was a bit long, but that's about it.
Thanks, Paul. That was excellent. A lot of information in there. and appreciate you joining us for the conference. Our next speaker is Lauren Redmond. She's an environmental scientist with the Durl project and coordinates the field work for domestic misconnections. We're just getting the slides up now. Okay, I think we can all see that.
Hi, thank you, Richard. Okay, so I'll be talking today about the optimization of misconnection detection resources. So I'll just run through our misconnection assessment process, so our stages and timelines, the methods we use to contact the homeowners, the effort we put in and how effective those methods are, and some of our outcomes. And then I'll just discuss how we can apply that knowledge when we're assessing new catchments, and hopefully other local authorities in attendance here might be able to use some of that information. So this is an overview of our misconnection assessment process. It shows the steps we go through to gain access to houses for assessment and how we follow up on misconnected houses to ensure they're repaired. So stage one is our drop card process. This is where we knock the door, and if there's no answer, we hand deliver a letter to the house. If we don't get access during that process, we move on to stage 1B, which is pre-enforcement 1 process, where we make additional contacts with the property to try and gain access. If we're still not successful there, we move on to stage 2, which is our enforcement 1 process, and this is posted letters out to the registered homeowners of the houses. So during those 3 stages, we manage to make contact with the homeowner and gain access for assessment. If the house is connected, we can close off that, there's no issue, and if it's misconnected, we move on to stage 3, which is our reminder process. And this is a series of phone calls to the homeowners. So we notify them of the misconnection, and 6 weeks later, we follow up to see how they're getting on with the repair. And we have a second and third reminder call 2 weeks following and 2 weeks following that. Most people fix their misconnections within that time frame. If there's no effort, however, to fix the misconnection, they might be ignoring us or not making contact with us. We move on to stage 4, the enforcement 2 process, and here's where we send non-compliance letters. When the misconnections are repaired, we then arrange a confirmed corrective visit to view the fix, and then we can close out those properties. So the rest of my presentation today will just focus on this gaining access for assessment, how we go about this. So in our drop card process, we first deliver an introductory letter to each of the houses in the estate. So this just introduces the Durl project, who we are, why are we in their area, and letting them know that we'll be calling to their house to arrange an assessment, and also directs people to our website for more information. A week later, we call to the house. If there's an answer, we explain who we are and that we need to assess their house's drainage on the outside of their house. And if there's no answer, we leave a drop card letter 1. So these drop card letters, they reiterate the environmental aims of the project, explain the pipes we need access to around their house, and it asks them to contact one of the stormwater assessors working in their area. And the second and third letters follow a similar vein. They just note that checks are necessary under the Water Pollution Act. So on our bar chart here, it shows the percentage of houses that are assessed at each card drop step. So you can see at card drop 1, we actually get into 46% of houses. So it's a pretty good hit rate. You know, generally there's someone at home and we get talking to them and they've no problem with us looking around the outside of their house. And then at drop card 2, a further 19% of houses, and drop card 3, a further 14% of houses. So actually at the end of stage 1, 80% of properties are assessed, and that's over a 6-week period. So it's a pretty high access rate during this stage. Moving on then, 2 weeks later we move to the pre-enforcement 1 process. So during this we make additional house calls. We particularly tried to call to houses on different days and at different times to increase the likelihood of catching homeowners. Some people work from home some days, in the office other days, for example. We also, the stormwater assessors work one Saturday a month and make house calls then for people who, just aren't at home during working hours during the week. And at each of these visits, the stormwater assessors leave a complimentary slip, just with a message to let the homeowner know that we called to the house, we missed them. You can see an example on screen here. This comp slip also has our logos and QR code to our website. So for these houses that we don't assess a drop card process, the average number of additional contacts is 1.8 visits. There also, to note, there's some homeowners who, they might ring us up after card drop 3 and say, oh, I'm actually on holidays for a month. Can you get back to me when I'm back? Some want to have their partner present, who's only available on Saturdays, so we might have to wait until our next working Saturday. Some may be working from home, want us to come back in a few days' time. So we kind of can pick up those sort of houses during this stage. And we assess a further 15% of houses. So at the end of this process, 95% of houses are assessed before any non-compliance letters are sent. For those few that we haven't heard back from, we now move on to the enforcement 1 stage, and this is where we send non-compliance letters which are posted out to the houses. So just to note, it's not a statutory notice, it's a non-compliance letter. The letters say they're concerned, or we're concerned that they're not making an attempt to contact us, and it will require us to serve a legal enforcement notice if we can't access their property to check the outside drains. So it just reminds them of their regulatory obligations under the Water Pollution Act. And example there on the screen of the first, second, and third letters, so you can see we just use a bit more red text, a bit more bold font as the letters progress. Also at the stage of the second letter, we carry out a land registry check on the property and send the letter to the registered homeowners. So it's proved useful if the house is rented or vacant, we can access, get contact with the homeowner that way. And then our access rates, we only have 5% of our houses left. We assess a further 3% after sending the first letter, and then to a lesser response to the second and third letter. And just an interesting thing to note that when we're looking at the numbers, the misconnection rate is actually higher for houses that need to be sent this enforcement 1 letter. So it's 11.4% of houses as opposed to 8. So it kind of suggests that some people are aware they may have a misconnection. They're less willing to let us in to assess their property. It just requires this bit of extra effort to gain access to their houses. So this bar chart is those previous graphs combined onto one, so showing the access rate at each stage. And the blue line is the mean number of contacts made with a property at each stage. So card drop 1, 2, and 3 is 1, 2, and 3 visits. Then we have at the pre-enforcement 1 stage an additional effort of 1.8 contacts plus another visit when we go and actually do the assessment, and then a further contact for each letter. And here again we have the same bar chart, and the green line shows the access rate at each stage. So for example, at card drop 3, we assess on the bar chart there 14% of the overall number of houses, but our access rate for the houses we call into is 42% at that stage. So card drop 1, 2, and 3, the access rate is between 36 and 46%, and drop card 1 is the most effective. And after drop card 3, so we put in a bit more effort with those additional calls, those Saturday calls, but we assess 76% of the remaining houses. So we see that does work. And then after sending the first enforcement letter, about 55% of houses get back to us, and we get into them. And then we see a lesser result from the second and third letter. So just some of the outcomes from our process that we use. Our assessment rate is 99.5%. We'd make a median number of 2 visits and then a weighted average of 2.45 visits. So currently we've assessed over 8,650 individual houses, and this would equate to over 21,000 contacts with homeowners. Okay, so now how can we apply this knowledge on our access rate and misconnections to assess new catchments in the most efficient way? And also, how long would it take to assess new catchments of different sizes? So the first step is to see how many houses there are to assess. So you identify a polluted outfall to the river, and you can find out how many properties' stormwater lines are flowing into this. And then during the Durl project, we've tested a high-risk approach. So the aim of this is to find more misconnections per number of assessments to maximize efficiency and the use of our resources. So we first see how many high-risk houses are in the catchment. So a high-risk house is a house with an extension, an outbuilding, so a separate building in the garden, or both. So we identified these using Google Earth and recorded this information on a GIS app. So on the photo on screen here, using this is a screenshot from Google Earth, you can easily see like these 2 houses. Can you see my laser? Yeah. Have no modifications. These two houses in the middle both have extensions. This house here has an outbuilding. This has an outbuilding. So that's the process we use to identify these high-risk houses. And in the catchments we're working on, the average number, there's an average of 41% of houses have been high risk. Why are we doing the high-risk houses? Well, if we look at the graph there, the red points on the graph show the misconnection rate for houses with modifications. So houses with extension, it's about 11.1%. With an extension and an outbuilding, 10.5%. With an outbuilding, 9.3%. But houses with no modifications, the misconnection rate's only 4.2%. So you can focus your effort on these high-risk houses. We've also found there's a higher chance of finding misconnections in larger houses, older houses, and detached or semi-detached houses. So it could be something you might consider as well. The next step then is to decide on the number of stormwater assessor teams to carry out the work. So we have 2 stormwater assessors per team that work together. With a full workload, one team assesses an average of 25 houses per week, as well as doing their reminder calls, their confirmed corrected, their comp slips. So the number of teams used will depend on, firstly, the number of houses you need to assess, the staff available to do the work, and then the timeline for completion of the works. So based on the percentage of houses assessed at each stage I showed you previously, we calculated how long it would take to assess various size catchments with 1 and 2 teams. So on the graph there you can see the number of houses in the catchments on the x-axis and time on the y-axis. So 1 team is in blue, and if you're using 2 teams in orange. So for these smaller catchments, you don't save as much time by having 2 teams, but in larger ones, you can complete the works a lot more quickly. So for example, if you have 1,000 houses here and 1 team, it would take you about 52 weeks to do the work, whereas if you have 2 teams, it would only take you 32. Okay. These graphs here, they have number of weeks on the x-axis and the percentage workload on the y-axis for both 1 and 2 teams. So while there are still drop card ones to do, the teams are working at 100% capacity. So for example, with 500 houses here, with 1 team, there'd be 19 weeks of 100% capacity workload, whereas if you use 2 teams, there'd be 9 weeks. But when these drop card ones are complete, the drop card stage is complete, 80% of properties are assessed, so there's no new drop cards, your workloads are going to reduce. So these final 12 weeks here on each of the graphs are finishing up drop card 2s and 3s, doing your pre-enforcement 1 stage, and then sending your non-compliance letters. So for smaller catchments, for example, the 100 houses here, there's no point in having 2 teams because you have to wait your 2 weeks in between each stage. There's just not enough work. Whereas in a larger catchment, it might be something to consider. For like optimum staffing resources, in some situations, maybe best to utilize 2 teams when you have your drop card ones, and then you could reduce down to 1 team to follow up on misconnections. And just to note that these timelines, this is gaining access for assessment, so they don't include the misconnections that need to be followed up. So those reminder calls and potentially the enforcement to non-compliance letters. So during the process, most connections will kind of be repaired, but particularly if you find some later on in this stage, you'll need to have a staff member to follow up on these as time goes on. Okay, thank you very much.
Thank you, Lauren. That was great. Just a reminder on Slido, if people want to pose a question, they'll have if they follow the link, and they can go to just put in the hashtag DURL. So just type in the letters DURL, and you can pose your question on Slido. So our next presentation is from the people that do all the hard work in the field. It's 4 stormwater assessors who have assessed thousands and thousands of houses, are probably the European experts on domestic misconnections, and probably have seen every type available. So our first person to present is Wesley Sinclair, followed by Gerard Spain, followed by Fergal Nugent, followed by Sylvester Asidu-Apia. So over to you, Sylvester.
Thanks, Richard. Good morning, everybody. My name is Wesley Sinclair. I'm a stormwater assessor for the Durl project, based in the River Griffin catchment area. You're very welcome to our stormwater assessor presentation today. So in this presentation, we're going to discuss the role of a stormwater assessor and how we conduct misconnection assessments with reference to a few examples. Gerard will talk about the aspect of homeowner engagement and awareness and how we get the public on board with the Durl project through consistency, perseverance, and the promotion of our local rivers and environment. Fergal and Sylvester will then discuss case studies where contractors have repaired their mistakes free of charge and how community networks can be a great resource in repairing those misconnections. So, on the next slide there. So, this is just discussing what the ground staff, the guys that are on dealing with the public on a day-to-day basis, stormwater assessors, what we do on an average day. So, first of all, on arrival and with access given by the homeowner to the property, the first thing the stormwater assessors will look out for is to identify the foul and surface combine manholes, and then also to identify the foul and surface AJs. So if you look on the, I'll just put it here, on the left-hand side here, that's an exposed combine, and this is a covered one here. Okay, so a combine then will take roughly 6 to 10 houses, take waste or stormwater, and take it from the premises out to the main sewer stormwater manholes on the main road. Another thing is then on the slide on the right here, this is when we gain access. So the first things we look for, as I said previous, is this is an AJ, and here's another AJ. We won't know whether they're stormwater or surface water until we actually lift the lids and expose what's underneath. And then up here then, further on up, we'd be looking also for toilet and appliance pipes that may be sticking out from the premises, and also if the premises has an extension or outbuilding, if we go further down, or is it just an as-built house from the start. Then after we've exposed all this, we perform our checks. So some of the checks that we do at the house, first one would be a visual test, and that would be to expose the AJs, and can we see pollution in the surface water combines or AJs. So if you just look here on the second slide here, that's an overview of an exposed combine manhole, and you can possibly see some grey scouring or staining in the bottom, in the channel there, and that would indicate to ourselves that there may be a source of pollution going into surface water combine. The next test then that we would do would be a dye test, and this would involve, we would use this if there was no access to the combines or the AJs, or to confirm a misconnection. With this method, we would use an aluminous dye, more often than not the aluminous green that you may see here in the exposed AJ. What we'll do is we put that down surface water gully, or as somebody previously said, a homeowner may put it down their sink or tap. We would then follow it out onto the main road to main manholes. So we'd open up the main manholes on the road, and the dye would eventually flow through, and then this would we could distinguish whether it is what's called a misconnection, i.e. going into the stormwater as opposed to going into the foul. So that's that slide finished. So just 2 case studies I want to go through now. So this one here, this is an example of an obvious misconnected upstairs shower pipe plumbed into a stormwater gully. So if you just look on the left here, you can see the shower pipe coming from upstairs, running down alongside a rainwater downpipe, and then it's going into a rainwater or stormwater gully, which is incorrect. What we did then was we opened the AJ, which is on the second slide here, and once again you can probably see the grey scouring, that's coming from the pollution from the upstairs shower. At this point then, let me see. At this point that we identified the correct foul gully at the rear of the property. Just show you here. So just over here, this is the back of the property here, and that's where the original waste or foul gully is. So we identified that for the homeowner and advised them of the correct fix. This whole fix here was fixed within 24 hours by the homeowner at a total cost of €50, as all he did was just extended the pipe, went to his local DIY, extended the pipe around and into the correct foul gully. So an easy fix, €50. homeowner wasn't in the trade, and he was able to do it within 1 day. And the second one here then, second case study, this is an example of a misconnected washing machine in a side extension. So the homeowner had only moved into this premises 7 months ago, and so the previous owner had done the misconnection when getting the side extension done here that you can see. They built over the side entrance and built the property there over the side entrance. So this is a little bit more difficult. So we had to, this one required a dye test. So you can see here, we exposed the AJ. We would have put the aluminous dye into the gully. We would have saw it going through the AJ, and then we would have chased this out just where the side wall is here. The main road is on the far side, so we would have opened the foul and the surface manholes on the road, and eventually it trickles through, and we were able to identify it as a misconnection into the stormwater network. Let me see. So maybe we'll just show you the next one here. So this work was then fixed by a contractor. What he did was he just ran a pipe up the side where the original misconnection was. He ran it up there. I don't have my finger I'm pressing, sorry. So you can see here where the arrow is, cursor is. What they did was then they dug a channel from that point straight across into the existing foul gully. A neat job, as you can see, as you can appreciate there. It's one of the best kind of ones that we've seen. So that was fixed at a total cost of €300 to the homeowner. And then just to say, when in our time as stormwater assessors finding domestic misconnections, most homeowners are very obliging in fixing the misconnection once they understand that their property is causing pollution to the local rivers, because they'd have kids and they may walk their dogs, etc., into local parks. So as soon as we explain it to them what's happening and what they need to do, 99% of the people are willing to fix it in a timely manner. That's the end of my presentation. I'm just going to pass it on to Jerry Spain here to go through his case study. Thanks very much.
Okay, great stuff. Good morning and thank you, Wes. My name is Jared Spain. I'm a stormwater assessor out in Dunleary, Rathdown. Part of my presentation is engaging and awareness with the homeowners. Part of the process of engaging with householders is through our letters and our leaflet drops. The leaflets contain further information which can be gained on our website with regards to the project. We have also carried out green estates demonstrations in housing estates, and we've been asked quite a lot of questions by the residents of those estates, and we answered them for them, and we dispelled some of the myths around what we're doing. And while we're in estates, people will normally come up to us, and as most people know, Irish people are curious, so they will ask us questions, and we will answer their questions for them. As I say, we try to lay to rest a number of misconceptions on the project, and some of the questions we're asked is, why are you picking on my house? What gives you the right to do this? Where and which council are you with? And are you doing the other houses in the area? They always want to know, is everyone included? And obviously we say yes to allay their fears. But most people, when we call out, are cautious. And they're cautious because we arrive up in high-vis jackets. But we try to allay their fears for them. As part of the protocol of ongoing communication through drop cards and letters and comm slips, we endeavour to engage with householders at various times of the day, as Lauren, previous speaker, has alluded to. And we tried to get there, arrange things on a Saturday. I'm going to go to the next slide. This is a case study in Carrick Mines. We were after trying to get into this house for 8 weeks to carry out the survey. If you see at the bottom there, we put a complimentary slip in his house on the Friday. And we happened to be out in that estate working on a Saturday. So we took the opportunity to drive around by the house, and we actually caught the homeowner going into the house. So we were able to talk to him. We explained what we wanted and the project that we were doing, and he had no issue with us doing it. The strange thing, or the funny thing, was the guy was a building inspector, and he worked for one of the councils. So he actually didn't want us in the house. But when we went through the process with him, he had no problem with it. We carried out the survey. He was connected, everything was connected in the right places. His home, actually, there was extensions to the back and to the side. He really had done a number on the house. He then informed us that he was part of a WhatsApp group for the estate. So I asked him, would he kindly WhatsApp his neighbours or other residents that we needed to survey the house. There were a few in there that we had got to the drop card 3 stage, and when he informed them that what we were doing, we got access into those houses, and we were able to do it. This slide here, this is an elderly couple, and again, elderly people are very cautious of who calls to the doors now, especially with guys arriving in the high-vis vest. We both, my colleague and myself, showed them our IDs and our authorizations. We didn't carry out the assessment at that time because we wanted them to confirm for themselves that we were legitimate. So we told them to contact Lauren in the office. If Lauren wasn't there, another colleague, Jane, would have been there, and they would have confirmed, and which they did. They confirmed that we were stormwater assessors. We then made an appointment to come back at their convenience when both people were in the house. We carried out the survey. Unfortunately, they were misconnected, but fortunately, they had a son who was pretty handy, and he did the repair, as you can see there. Thank you so much for listening to me. I'd now like to hand over to Fergal.
Yeah, thanks, Jerry. My name's Fergal Nugent, stormwater assessor. On our day-to-day visits, we come across several different scenarios. Here's one where the lady has just finished, probably 4 months previous, one-story extension, beautiful job, porcelain tiles, rear patio. We come in, we assess the foul on the surface water, and to the back here we can see that's the surface drains. We get the lady to pour some dye down her sink in her new island, and of course we trace it to the manhole out on the road, and it's misconnected. Obviously, it's a hard news break for a lady who's probably spent maybe 100 grand on a new extension, but we always try and work out the easiest way to fix it. So she contacts the builder, and the builder comes out, realises that he has mistook the surface drain for the foul. He reroutes the pipes round to the far side to the foul manhole. Job done. In this case, the homeowner actually gets us out to examine before the tiles go back down that everything's 100%. So we gladly go out and we see that everything's been done correctly, and happy days, the homeowner, everyone's happy. So that was one. Next one, homeowner had some minor works done in the kitchen. They had repositioned the kitchen sink. So the plumber inadvertently, as we see there, puts the kitchen sink into the storm drain, and when obviously the homeowner doesn't know till we come out, examine it, and they contact their builder. Builder gladly comes out. It's a pretty easy fix. The foul drain is there pretty much beside it, and no cost fixes the misconnection. And lastly, this was one that was to and fro for a while. The homeowner had renovations done in the kitchen sink moved, dishwasher misconnected. Builder was denying that there was any problem or there was any problem that he had caused, but we arranged to meet the builder and the homeowner. We do the dye test, and yes, it's confirmed misconnection. We find a foul drain close by, so easy enough fix. The builder agrees to come out, fix up make good his work, and leaves it 100%. Everyone was happy. By and large, in this project, we were just heard all the other speakers saying how hard it is to get into properties, but I think when you develop a rapport with going door to door every day, it's been pretty easy, and everybody has bought into it. And actually, I work with Wes there on the team. We explain everything to the homeowners, and they're actually happy when the misconnection is found. And as we always try, I've worked in the building trade before this myself. We always try and find the easiest way to fix it and put the homeowner at ease. And most of them are 95% are easy fixes. So they're actually glad that it's been found, and no one wants to be the polluter. That's what I see out there. So it's been a very, very worthwhile project in that way. I'll just pass you on to the next speaker, Sylvester.
Thank you, Fergal. So the image on the screen is an old estate in Dublin. It was built in the early 1970s, and originally the houses had outbuilding and boiler houses, and most of them it didn't come with any appliances, but most of the houses decided to use as utility rooms. So they put washing machines in there. When we assessed these estates, we found 21% misconnection rates, of which 64 were sinks and washing machines in the outbuildings. This is an example of one of the properties in the estates that was misconnected. The homeowner did not have anybody to fix the misconnection. So finding a tradesperson was a barrier to the homeowners fixing their misconnections. The most common questions that we get is, who can I get to repair my misconnection? Therefore, we worked with the National Guild of Mastercraft to publish lists of registered tradespersons local to our areas who repairs misconnections. We contacted each tradesperson and asked them if they did misconnection repair works. If they did, we added them to our list, which is published on the National Guild website to homeowners to have access to. We provide homeowners with an information leaflet on misconnection repairs, which has detailed on getting a quote and how to contact Age Action, Care and Repair, and the National Guild of Mastercraft. We provide homeowners with all the necessary information they need to enable speedy repairs. This homeowner shows on the screen employed a tradesperson from the National Guild to fix their misconnection he did in a nice way and in a quick time frame manner. As you can see, this is before and after work that was done. That's the after. Right, the community networks. This is the second house that was also in the same estate. Due to the strong links between neighbors, word of mouth got around, and the same trade person was recommended to other houses. Looking at the example on the screen, he fixed this within a few days and charged reasonable cost of €100. So, community network works. So this is the before and after work. This is the nice work that he did. Griffin Estates. This is another estate that had strong community network. Residents complained of bad odors. We needed to do a dye test and found that the surface water manhole was blocked and very polluted. We arranged for a jailer to clear the manhole. The residents were very happy and the odor issues resolved. They were happy to let us in to do the assessment, and we found sink, dishwasher, and washing machines were misconnected in 8 houses. A retired builder who lives in that estate had spare materials in his shed, repaired 5 of the misconnections at no cost or minimal material costs. The strong community network greatly assisted with this getting the misconnection repaired in the estate. This is the work of the retired builder. And so this is the end of the presentation. Thank you very much.
Great, thank you, Sylvester. We're going to have questions and answers now. I believe, Paul, are you still available to take a question?
Yep.
Great. I'm super nervous and super impressed at the same time. If I could invite Wesley back up and Lauren back up, please, as well. And you can, Paul, you can be the virtual seat here as well. Do we have any questions from the audience? Paul, I have a question for you. We hear a lot about Olympics and the cost of infrastructure. Could this be the first Olympics where people are investing in water quality and environment?
That's a good question. I don't know if it's the first time. At least it's a time where there's a lot of money put in getting the water quality to improve. As you know, I think what the figures are around 1.2 billion euros spent to get the water quality of the Seine improved. I think there's been other examples. I know that there's been some swimming happening in Rio or in Japan. I'm not sure of how much money they spent and how it improved the water quality. But what's for sure is that I think the will to improve the water quality is quite obvious by the money that's been put on the table to improve the water quality of the Seine this year.
Okay. Certainly we have a question from the audience. Thanks, Paul.
Hi, Emma Kennedy here from the City Council. It's for Lauren. I'm just wondering, you mentioned you sent out a lot of compliance letters. Have you had to use any statutory notices to get people to?
Great. So just for our online audience, the question is, have we had to issue any statutory notices? And that's for Lauren to answer.
Hi, Emma. No, we haven't yet. So it was decided kind of early on the project, since we were assessing thousands and thousands of houses, we wanted to keep the door open to get into as many of them as possible and wait a bit to go down that enforcement route. So now that we're coming to the sort of end of the project, we'll be going back to those few houses we haven't gotten into and doing that at this stage, rather than doing it at the beginning and maybe jeopardising some of the houses that we might not have been able to get into if we went down that route there. So it's on the cards for the future.
And now that we've got the first question on the floor, anybody else? Michael?
Thanks very much for all
households, and contrasting that with the approach that's taken here in terms of polluter phase. Do you recall of any observations on that and where that grant is coming from?
Okay, Paul, that was a question from you from the floor. Do you have any observation? You're providing monetary support to fix misconnections versus we're using the Durl project is using the polluter pays principle. Easier said than said. So if you have any observations on that, you're probably under pressure with the Olympics, maybe.
Yeah, I think that's part of the answer, for sure. Yeah, I understand the polluter pay principle, but for sure we see that we've been struggling even with the incentive, and I think there's been quite a lot of there's been quite a lot of money put on the table, and still people are quite reluctant. We've seen it. I haven't discussed that, but we've also seen it with the boats, where there was public subsidies for them to connect to the wastewater network. Even with the money that's been put on the table, it's been quite hard to get people to connect to the network in such a restrained time frame, because literally I think that started in 2020, so during COVID. So we had basically had 4 years to fix that. So yeah, I understand the question, but I think because of the time constraints, we had to put some money on the table and to help fix that.
Okay, thank you, Paul. Just one maybe last question for Lauren again, because a question I have, you don't just go in and pick every house. There's a screening process or something like that. Am I right?
Yeah, so once there's a polluted outfall into the river identified, we then do manhole screening. So we'd go to an area and pick key manholes, that take different rows of houses, and open them, and we have another GIS app to record that information, and they're marked as clean or dirty in the source that we see. So we know if we need to watch out for toilets or if it's more wash machines, kitchen sinks, that sort of thing. So then from those polluted manholes, we know which houses are going to them. So we'll do our high-risk approach on those houses rather than doing the whole estate when some of those manholes may be clean. We don't need to go into those houses.